We tend to think of AI as something we build to do a specific job. But what if that entire approach is just fundamentally wrong? Today, we are diving into a really radical idea that could shift how we develop AI, moving it away from just optimizing a task and towards something more like genuine, open-ended growth. Let's get into it.
I mean, you see the headlines, right? It feels like there's some new, mind-blowing AI breakthrough every single week. We're talking photorealistic art from a text prompt, complex software that gets written in seconds, AIs that can beat the best human players at the most complicated games. The capabilities are just staggering, at least in these very, very specific areas.
But here's the thing. With all this incredible power, are we actually building on solid ground? What if the very method we're using to create these amazing tools has a deep, hidden flaw? One that makes them incredibly powerful, yeah, but also incredibly fragile.
Well, that hidden flaw actually has a name. It's called the brittleness problem. And it's this idea that our AI, for all of its incredible strength in one specific area, can just completely fall apart the second the situation changes, even just a little bit.
So how do we end up with these brittle systems? Well, it really comes down to the way we build most AI today. It follows this really rigid four-step recipe. First, we define a super specific goal, like winning at chess. Then we collect an absolutely massive amount of training data, every chess game ever played. Third, we just optimize the AI's internal knobs and dials to get the best possible score on that data. And finally, when it can't get any better, we deploy it. And what you get is a powerful but totally frozen snapshot of what it can do.
So why does that make it so fragile? Well, there are three big reasons. First, by being so specific about the goal, the AI has zero flexibility to handle anything that looks new. Second, the whole training process is designed to remove any and all friction. But it's that struggle, that friction, that actually forces real learning. And finally, the AI's core structure, its architecture, is totally fixed. It can get better and better at its one little trick, but it can never, ever learn a new one.
Okay, so if that old model is broken, what's the alternative? This is where things get really interesting. The proposed solution is a radically human one. Instead of building an AI to achieve a goal, what if we built an AI that could develop an identity? Now that is a fundamental shift in how we think about this stuff.
And this slide just nails the difference perfectly. A goal, right, like I want to lose 20 pounds, that's just a target. It's an outcome you're shooting for. But an identity, I am a person who exercises, that's a process. It actually changes your default behavior. The identity makes the goal a natural side effect, not this constant uphill battle. The goal is what you do, the identity is what you are.
So that sounds great in theory, but how in the world do you actually build an AI that has an identity? Well, the framework that's been proposed is like a blueprint. It has three distinct layers that all have to work together to let an AI truly grow and evolve over time.
All right, layer one. It's called structural plasticity. And this is a huge departure from what we do now. It basically means the AI isn't stuck with the brain it was built with. It can actually fundamentally reorganize its own internal wiring, its virtual neurons, its connections, whenever it realizes its current setup just isn't cutting it for a new problem.
Now, for this to work, the AI needs a few things baked in. Its architecture has to be modular, kind of like Lego bricks, so different parts can be swapped out and reconnected. It needs meta-learning, which is the ability to even recognize when it's failing and needs to change its own structure. And it needs something called a plasticity budget, which basically stops it from changing too fast and becoming chaotic. Let's just put this in human terms for a second. When you get really, truly stuck on a problem, the answer isn't just to try harder and harder at the same failed approach. It's to step back and think about the problem in a completely new way. That's structural plasticity. It's the ability to rewire your own thinking. But, an AI can't just change in a vacuum. And that brings us to the second layer, coupling dynamics. What this means is the AI has to be deeply connected to a real environment that actually pushes back, an environment with genuine feedback and real, lasting consequences. And for this to be meaningful, the environment has to play by some rules. There's no hitting the reset button. Actions have to have real costs that pile up, just like in real life. The system also has to be able to tell the difference between a simple mistake it can fix and a deep, fundamental failure that means it needs to restructure itself. And you need ways to stop it from just cheating or gaming the system to get a good score without actually learning anything. This is really the difference between practicing in a sterile, safe simulator and actually performing in the real world. It's how an AI can truly learn from experience in a way that forces deep, meaningful change, instead of just optimizing for a higher score on some static test. Real consequences are what drive real growth.
Okay, so we've got an AI that can change itself and an environment that forces it to change. What's the last piece of the puzzle? Well, it's not enough to change for the better. You need a way to make those positive changes stick. And that is the third and final layer. It's called Constraint Geometry, and it's all about creating systems that lock in that new, more capable identity and make it really hard for the AI to slide backwards.
So how do you make these changes permanent? A few key ways. You need honesty enforcement, which is like an unchangeable log or a mirror the AI can't lie to about its past failures. It needs to be able to make irreversible commitments. You know, the classic example of Cortez burning his ships when he arrived in the Americas. There's no going back. And it needs to be able to detect when it's starting to drift back towards its old, less effective habit.
At the end of the day, this is exactly how we as humans make new habits permanent. We change our environment, we tell our friends to hold us accountable, we make public commitments. This layer does the same thing for an AI. It makes its new, better identity the new default setting, the path of least resistance.
So let's just put this all side by side because the difference is really night and day. On the one hand, you have standard deep learning. The architecture is fixed. The goal is just to optimize a score. The environment is a static data set, and its state is frozen after training. On the other hand, you have identity architecture. The architecture is mutable. It can change. The goal isn't to get a high score, but to reduce its own shortcomings. The environment is dynamic and coupled. And most importantly, it never stops evolving. It's a completely different ballgame.
Okay, so this is a really cool technical idea, but why should you actually care? Why does it matter so much? Well, because shifting from optimization to identity could have absolutely profound implications for the three biggest challenges we face in AI: safety, capability, and alignment.
The payoffs here are just enormous. With this kind of architecture, we get safer AI because the systems are auditable and they're forced to be honest about their own limits. We get truly open-ended capability because they can evolve brand new structures instead of just hitting a wall. We get alignment not by trying to write some perfect reward function, which is basically impossible, but by designing environments where the right behavior is just the natural outcome. And incredibly, it might even lead to cooperation emerging naturally between different AI systems.
Look, what we're really talking about here is more than just a new technique. It's a whole new philosophy. It's a shift away from this factory model of building a static tool and more towards a gardening model where you're cultivating a living, growing system.
And it all boils down to this one really powerful idea. The real work isn't optimizing outcomes, it's growing capable architectures. We stop being just programmers trying to force a specific result, and we become more like architects, designing systems that have the potential for genuine, unpredictable, open-ended growth.
And that really leaves us with a final, pretty provocative thought. We have spent decades building machines that can learn from data. But what happens to our world, and what happens to us, when we start building machines that can not only learn, but truly evolve? Thanks for tuning in.